Hey guys, so today we are going to solve problem 153 of Leetcode, finding minimum in rotated sorted array. And this is a popular question, so we'll try to solve this and give a good solution for that. So suppose an array of length n sorted in ascending order is rotated between 1 to n times. And for example, the array is 0 to 7. Okay, so it will become 4, 5, 6, 7, 0, 1, 2 if it was rotated 4 times. We'll see how this rotation is being done. So if you see this array, so after rotating it by one time, it will become something like this, like last element is coming to the front and all the elements are moving towards one position to the right? And other things which I mentioned is this is all the elements in this array is unique. Okay, and the minimum, we need to find the minimum of this array, and the time complexity should be O of log n. Okay, we'll go through some of the examples. Like if it is 3 4 5 1 2, then expected output is 1, as the original array was this and it was rotated 3 times. Okay, in second it will be 0, as it was this and it was rotated 4 times, and in this case it was not at all rotated, so it will become, or it was rotated equals to 4 times, which is the length of array, so it will become the original array, and in this case the output will be 11. So we'll try to come up with the algorithm and then we'll try to code it out. So yeah, we'll take example 2 and let's see how the result was calculated for that. So if we take 4 5 6 7 0 1 2, we'll put their indexes such that it will be easy for us to reference them. So 5 6. So before going to the most efficient way, we'll see what was the most brute force way of doing this. So what we could have done was a linear scan, right? Linear scan maintaining the min variable and then storing, comparing it with each element and returning at the end. So that would have taken, as we are comparing with each element, it would have taken O of n time complexity. But the ask of the question is we need to do it in O of log n. By O of log n, what we can derive is the search space is getting half and half every time. By this we can recall as the similar type of algorithm which exists as binary search, right? And the condition for binary search was the search space should be rotated. Anyway, in the question it is properly stated that our input was initially in ascending order before it was rotated, but after rotated it is sorted but it is skewed. So we need to skew our binary search algorithm to make it work, right? So let's derive some of the base cases, like how we will know a certain array is rotated or not. So in the question it is mentioned that array is sorted in ascending order, right? That means the first element should be less than the last element. The reason I'm not putting equal to in this case is all the elements are unique, so it will be strictly less than. So whenever this condition is being satisfied, that means the given search space is sorted. And in this case, what we can do is we can simply return the first element. So nums of left is always going to be our minimum element, right? Now we know in case when it is not sorted how we are going to return the minimum. But what if it is skewed, right? If it is rotated, then how we are going to solve it? So when it is skewed, then that means the minimum is going to lie somewhere on the left side or on the right side. Okay, so if we calculate the mid will be third index, right? So as you can see, the left half of this is sorted, right? If you compare the first and last element, so it is sorted, right? But right half is not at all sorted. So the order will be disrupted only when a smaller element or a minimum element is entering to space, right? So suppose if it was 4 5 6 1 2, so if it was going in like all the elements are increasing in a certain order, but at a certain instant, the disruption of the increasing order will happen. Like all the numbers are going in increasing order, but at zero, what will happen? It'll go down, and then again it will start. So what we need to find is this point, right, where it is going down, and this will be the next element, will be our minimum element, where this flow is breaking, where the ascending order is breaking. So how we can find that? So in order to find that, what we can do is we can simply remove the half which is already sorted, right? Because in sorted, this order is not breaking. The order is breaking where the half is not sorted. So we'll simply keep on reducing, and at the end, our binary search algorithm is going to narrow it down to the certain element where this disruption of the ascending order is happening, right? So we'll just code it out, and we'll try to understand the algorithm over there in a much better way, right? So let's go and write some code related to it. So what we'll do is we'll take a left variable and a right variable, which will be equals to nums of length minus 1. And while left is less than right, what I'm going to do is I'm going to check for every case whether it is sorted or not. So if it is sorted, the search space is sorted. That means if, how we are going to check if it is sorted or not in ascending order? So if it is nums of left is less than nums of right, then that means that it is sorted, and we can return nums of left, as it will be the minimum element, right? Else if it is not sorted, then what we are going to do is we are going to calculate the met, right? So left plus right minus, sorry, my keyboard is causing some problems. So, and how we are going to decide which half is sorted and where the disruption of the ascending order is happening? So we'll do simple comparison, which is array of left, not array, the given is nums, right? So nums of left, if it is less than or equals to mid, right, nums of mid, then what we are going to do is this half is sorted, so we'll search in the other half, which is nums of mid plus 1. Else the left half is sorted, right? So in that case, what we are going to do is we are going to assign right to mid. So we our search space will get reduced to left half. Now this algorithm is going to break once we have left equal right, right? So at the end, we are going to get to a certain element, that particular element where this ascending order is breaking. So there we are going to return that specific element where it is happening. So we are going to return nums of this. We are going to run this, and let's see. So we are getting the desired output, and the result is accepted. So yeah, thank you.